Learning Objective 2 from Section 6.3 is to interpret the slope coefficient and the y-intercept of a regression line in context as appropriate. In Section A 6.2, we interpreted the slope of a line as a rate of change. In other words, how much the y variable changed as the x variable changed. In other words, how the vertical change happened as x increased by 1 unit. The slope coefficient in a regression line is the same thing, except that it's not an exact rate of change. It is a predicted or an average rate of change. Because when we're dealing with a regression line, we're thinking about real life data, and there's variability. Not all of the points are going to fall exactly on the equation of the line. So here's an example. A county real estate appraiser wants to develop a statistical model to predict the appraised value of houses in a section of the county called East Meadow. One of the many variables thought to be an important predictor of appraised value is the number of rooms in the house. Consequently, the appraiser decided to fit the simple linear regression model y hat equals beta naught plus beta 1x, where y equals the appraised value of the house in thousands of dollars and x equals the number of rooms. In this regression equation, beta naught is the intercept and beta 1, the coefficient of the x term, is the slope. Using data collected for a sample of n equals 74 houses in East Meadow, the following regression equation was obtained. Y hat equals 74.80 plus 22.75x. Choose a practical interpretation of the estimate of the slope of the least squares line. So the slope is this value that is the coefficient of the x term, that's the 22.75. And it tells us how much y, the appraised value of the house, changes when x, the number of rooms in the house, increases by 1 unit, so by 1 room. So that's the interpretation that we're looking at, or looking for. Look in answer A. For each additional room in the house, that tells us that x is increasing by 1. We estimate the appraised value to increase by $22,750. Remember that these values are given in thousands of dollars. So 22.75 in thousands of dollars is $22,750. So that is the correct interpretation. For the slope. Let's look at the other answers. For each additional dollar of appraised value, we estimate the number of rooms in the house to increase by 22.75 rooms. This answer has the roles of x and y switched. The slope is the average change in y when x increases by 1 unit. For each additional room in the house, we expect the appraised value to increase by $74,800. This answer has the x and the y roles correct, but it uses the value for the intercept, that 74.8, rather than the value for the slope. And then D, for a house with 0 rooms, we estimate the appraised value to be $74,800. Answer D is actually the interpretation for the y-intercept. The y-intercept gives us the expected or estimated value of y when x equals 0. This next example will let us interpret both the slope and the intercept. 16 college student volunteers each drank a randomly assigned number of cans of beer. 30 minutes later, a police officer measured their blood alcohol content, or BAC, in grams of alcohol per deciliter of blood. The scatter plot is given below, and the regression equation obtained is y hat equals negative 0.0127 plus 0.0180x. Give an interpretation of the slope and intercept of the regression equation. You can see from the scatter plot here that our x variable is number of cans of beer, and our y variable is the blood alcohol content. So to interpret the slope, remember it is for each additional unit of x, so for each 1 unit increase in x, the slope gives us the expected or average change in y. So for this example, we would say something like, for each additional can of beer that a college student drinks, BAC increases by 0.0180 on average. We're using the value for the slope, which is the coefficient of the x term in the regression equation. The intercept is the average or expected value of y when x equals 0. So, for example, in this particular situation, the intercept would be if a college student drinks 0 cans of beer, that's when our x equals 0, we expect the BAC to be negative 0.0127. Now, you can't actually have a BAC of a negative value, but that is the intercept of our equation, and so that would be the appropriate interpretation.